less than or equal than the limit inferior of the integrals. Correct? Yes or no?
Mm-hmm.
In other words, the integral of f of d mu is less than or equal than the limit of f and d mu. That's almost what we want. If you take a look in problem number 1, what is what we want, guys?
Integral e f d mu.
Equals the limit, not the limit inferior, right? And not less than or equal, we want equal. So we apply again Fatu. But this time I apply it to E complement, so we have the integral f of E complement d mu is less than or equal than the limit of the integral of fn on E complement. So now I separate this integral as the integral of f minus the integral of E. I, split it. So this is the same as the integral of f on the universe minus the integral of f on E. And the reason we can do this is because why can't we do this? Because this integral is finite. So therefore you are subtracting finite numbers. So your professor, this one is finite, but how about this one? And you're right. The integral of f mu on E is less than or equal than the integral of f on the universe, which is the same as you can erase the universe, and that's finite because of that. Therefore, each of these is a finite number. So this is finite, and this is finite. That's less than or equal than the lim m. You split this as the integral on the universe minus the integral on. Do you remember that we did this in class, guys? I was explaining this. Maybe it was at the end. How's your morning, guys?
Excellent. Thank you.
Likewise, we can split this because this is going to be, these numbers are going to be finite after some n, because this limit is finite. Maybe the first 5 million pieces, the integral is infinity, but because the limit is finite after some n, those guys are finite. Right, Victoria?
Mm-hmm.
So this is true after some n, and because we're taking limit inferior, it doesn't matter after some n pieces. So this is finite, and this is finite. Now, the lim inf of something is less than or equal than, so I think we are using the fact that the lim inf of an plus bn, if you wish we can put like a minus here, is less than or equal than the lim inf of an plus the lim sup of bn. I think that's the lemma. Do you guys remember the lemma?
Mm-hmm.
Yeah.
That's the lemma. You cannot put lim inf in both sides. It has to be.
Isn't it when they have a negative though, Professor? An minus bn? Then you take out the negative, it turns the lim inf into lim sup.
Oh yeah, that'll be another one. Hold on, is that hold on, maybe I'm wrong.
There's no negative in there, it's negative lim inf to lim sup.
Yeah, we can do that later, but right now I'm only applying this one. Well, it can be the other way around. It can be the other way around. It can be this one and this one. Yeah, because we can switch them. So therefore, this is less than or equal than the lim sup of the integral of f n d mu. Or it's even less than or equal than the lim sup. No, wait, no, that's good. So if I apply this here, it would be plus, you guys agree? Plus lim inf of minus the integral, and this is what Eric is talking about. There's a minus here, right? Now, but when you have a minus, a limit, when you have a minus, this minus can travel outside, but it reverses. You know, when you multiply by minus, it reverses things. So this minus, when it goes outside, it becomes lim what? Lim sup. So this is equal to lim sup of the integral of f n d mu minus lim sup the integral of f n e d mu. And then we finish saying, why do we finish here? Because this limit exists. So when the limit exists, it matches the lim inf and the lim sup, so it doesn't matter which one you put. The lim and the lim inf and the lim sup are going to match. So this is equal, in fact, to the integral of f. So this limit exists and is equal to, by that, say by 1, this is equal to what? Integral of f d mu. So what is the conclusion? Conclusion, this is less than or equal than that. You guys agree? So this is less than or equal than this, less than or equal than that, and blah, blah. So therefore, this minus the integral of f d mu is less than or equal than the integral of f d mu minus lim sup of the integral of f n d mu. So this cancels out because this is a finite number. You can, by the cancellation law, you can cancel it in both sides. And then you multiply by minus. Or I would suggest you move this to this side, move to that side, instead of multiplying by minus, which is the same thing. So therefore you have, what do you have after that then? After cancel this, cancel that, move this to the left, move this to the right, so it is positive. So I have, what? Lim sup of these integrals. Oh, hold on.
It should be an E.
There should be an E.
Yeah.
And here too, right? Yes?
Yep.
E d mu is less than or equal than the integral of f d mu.
E.
Right? E. So if you combine this box with this box, you get it. So let's call this star. So by star, the integral of f on E is less than or equal than the lim inf. This is by star. So when you combine this, you finish the problem. Just put these two things together and that's it. This is less than or equal than the lim inf, which is the lim inf is less than or equal than the lim sup of whatever, right? no more the infimum is less than the supremum. So Fn mu. Therefore, by the squeeze theorem, this matches that, so they are all equal. Hence, by squeeze theorem, by the squeeze theorem, what do we get, guys? That the lim inf matches the lim sup, right? And when the lim inf matches the lim sup, the limit exists and it's equal to either of those. By the squeeze theorem, so we have that the integral of f on e d mu is equal to the lim, and that's what we wanted. All right, let's do, which problem do we use from, do we do from chapter 5? 1, 2, 3, 4. How about the first one? Do you understand, guys?